If you're figuring out how to actually integrate AI, improve your platform, or make dev experience better for your team, InfoQ Dev Summit Boston 2025 might be worth checking out. It's 2 days in June, focused on the real-world side of adopting these technologies. You'll hear from senior engineers who've already been through it, what worked, what didn't, and what they'd do differently. It's built for teams who need to move now, not just stay inspired. Join us this June 9 to 10. Learn more at devsummit.infoq.com. Good day, folks. This is Shane Hastie for the InfoQ Engineering Culture Podcast. Today, I'm sitting down with Sergii Gorbachov. Sergii, welcome. Thank you for taking the time to talk to us today.
Thank you. Thank you for inviting me.
We met because you recently gave a really interesting talk at QCon San Francisco. Do you want to just give us the high-level picture of that talk?
Sounds good. The project that I presented was around code migration. It was the migration project that took about 10 months. We moved from Enzyme to React testing library. Those are the libraries that help you create tests to test React. And the interesting piece there was that I combined a traditional approach using AST or abstract syntax tree and LLMs. And together with the traditional and new approaches, I was able to save a lot of engineering hours and finish this project a lot faster than initially was planned.
So real-world hands-on implementation of the large language models in production code bases. But before we go any further, who is Sergii?
Sure, yeah, I can talk more about myself. My name is Sergii Gorbachov, and I'm a staff engineer at Slack. I'm part of the developer experience organization, and I'm a member of front-end test frameworks team. So I deal with anything front-end testing related.
What got you interested even in using the LLM models?
Well, first of all, of course, hype. You go on LinkedIn or you go to any kind of talks or conferences, you see that AI is very prominent. And I think everyone should probably learn about new technologies. So that was kind of the initial push for me. But also before Slack, I worked at a fintech company. It was called FinAI, where I built a testing framework for their chatbots. So I was already acquainted with some of the conversational systems that use artificial intelligence, not the large language models, but regular, more typical models. And then, of course, the reality of working as a front-end or software developer, engineer, and test, working with front-end technologies, that change quite often. I think JavaScript is notorious for all of these changes, and libraries change so drastically that there are so many breakage changes that you need to, in our case, rewrite 20,000 tests. And doing it manually would take too long. It would be about, we calculated 10 to 15,000 engineering hours if we went with the manual conversion and using developer time like that. At that time, Anthropic came out with one of their LLM large language models, and one of the use cases that people were talking about is code generation and conversion. So that's why we decided to try it. And of course, at that time, they were not very popular. There were not too many use cases that were successful. So we had to just try it out. And to be honest, we were desperate because that much amount of work, and we kind of had to do it and had to help ourselves.
What were the big learnings?
I'd say one of the biggest learnings is that AI by itself was not a very successful tool. I saw that it was kind of an overhyped technology, and if we use AI by itself to convert code A to code B, in our case, from one framework to another framework in the same language, so the scope was large, but not very wildly large. It was still not performing well, and we had to control the flow. We had to collect all the context ourselves, and we also had to use the conventional traditional approaches together with the AI. And I think that's That's kind of the main biggest learning, is that our traditional common things that we have been using for decades are still relevant, and AI just does not displace them completely. It only complements them. It's just another tool. It's useful, but it just cannot completely replace what we've been doing before.
But what does it change, particularly in how people interact and how our roles as developers change?
Sure. In this specific example for enzyme to RTL conversion, I'd say the biggest part of AI was the generation part, and large language models. Those are generative models, and that's where we saw that there were no other tools available in the industry. And usually that role is done by actual developers, where you, for example, convert something, you use those tools manually, and then you have to write the code. So that piece is now more automated, and in our case and for our project was done by the LLM models, and developers role shifted more to reviewing, fixing, verifying. So it was more of validation part that was done by the developers.
One of the consistent things that I'm hearing in the industry, and in almost any role adopting generative AI, is that shift from author to editor. But that is a mindset shift. If you're used to being the author, what does it take to become the editor, to be that reviewer rather than the creator?
Yeah. Well, that's more of a extreme use case. Maybe it exists in real life, but I would say realistically, you are a co-author. So yes, you're not you're a co-author with the AI system, and you still have to write code. You definitely spend a lot more time reviewing the code and guiding this system rather than writing everything yourself. And in that respect, I don't think that I personally, in my development experience, I don't miss that part, writing some of the scaffolding or code that is very straightforward, that I can just maybe copy paste from other sources. Right now, I can just ask the LM to do that easy bit for me, and go produce the code and write code myself that is more complex, where more thinking is necessary. But yes, definitely the role of a developer, at least in my experience, has shifted to more of a co-author and a person who drives this process. And to a certain extent, it's still also very empowering, because I'm in control of everything, but I'm just not the person who does all the work.
So we've been abstracting further and further away from the underlying bare metal, so to speak. And is this just another abstraction layer, or is there something different?
I think it's definitely another abstraction layer on top of our regular work, or another layer how we can interact with various coding languages or systems. But it could be the final one. What is going above just natural language, because that's how we interact with the models. You use natural language to build tools. So the next step is just implanting it in our brains and then controlling them with our minds, which I don't think will happen. But the difference, I think, with previous technologies that would change how developers work is that this is the final level, and we are able to use tools that we use in everyday life, like language, or like natural language. I guess this is the key, that it's so easy, and sometimes it's I guess it may be democratizing the process of writing software, because you don't really need to know some of those hardcore algorithms, or maybe sometimes learn how a specific programming language works. Rather, you need to understand the concepts, the systems, something more abstract and I guess intellectually challenging. And I see how many people changed in terms of how they write code. Let's say managers who typically do not write code, but they possess all of this very interesting information. For example, what qualities of a systems are important, so they can codify that knowledge, and then an AI system will just code it for them. Of course, there are some limitations of what an AI system can do, but the key here is that it enables some people, especially those who possess some of the knowledge, but they don't know the programming language.
So thinking of developer education, what would you say to a junior developer today? What should they learn?
My background is in social sciences and humanities, so maybe this whole shift fits me very well because I can operate at the kind of higher level where you think about, you take a system, you break it down, and when, for example, in humanities, you always look at the very non-deterministic systems, let's say languages or things that are more related to humans, and it's very hard to pinpoint what's going to happen next or how that system behaves. And I would suggest focusing more on system analysis or understanding, I guess, some of the, or like taking maybe more humanities classes that help you analyzing very complex things that we deal with every day, like talking to other people or relationships, psychological courses. And then that would give the ability or this apparatus to handle something so non-deterministic, like dealing with an LLM and being able to create the right prompts that would generate good code.
So if we think of the typical CI pipeline series of steps, how does that change? What do we hand over to the tools, and what do we still control?
I think we're still controlling the final product, and we still, I think, have the ownership of the code that we produce, regardless of what tools we use, AI or no AI tools. We still have to be responsible. We cannot just generate a lot of code. And today, generation is the easiest part. The most difficult part is that you have generated so much code that you don't know what it does. You don't know how to validate it. And long term, it could be problematic because there is a lot of duplication. Some of the abstractions are not created. So long term, I think we should still think about code quality and control kind of what we generate and what code is produced. As for the whole kind of experience, human experience, does it change with CI systems in particular? They have served very well for us to automate certain tasks. Let's say you create a PR, you write your code, and all of those tests, linters run there. And one of those, let's say, linters on steroids could be an AI system that would just check our code, and it would probably not change too much of our work today, but it will be able to provide us extra feedback that we should act on. And that's, I think, the reality right now. Long term, for example, another initiative that I've been working on is test generation. And there's a generation part that no other tools can do. So let's say a developer or you or me create a piece of code and then you do not cover it with tests. So in that case, you can hook up an AI system that would generate the tests, suggest it for you, and maybe create a background job that you would be able to come back later in 1 day or 2 days and fix those tests or add them, especially for features that are not production facing. Let's say it's a prototype. So it kind of changes how we might be doing our job, especially for testing, where it could switch how we view, for example, some of the tasks, if they can be outsourced to an AI system. And usually AI systems take longer than 10 to 20 minutes to produce that some artifact. Then we would just change our way of working rather than doing everything right away in an iterative fashion. We would just create the bare bones and then ask all of those systems to do something for us in the cloud, in CI systems, and come back the next day or in 2 days and continue on them, or just validate and verify that what has been produced is of good quality or not.
One of the things that we found in the engineering culture trends discussion recently was pull requests seem to be getting bigger. more code. And that's antithetical to the the advice that's been the core for the last well, certainly since DevOps was a thing. How is
Right.
this impacting us?
I guess one of the metrics that I sometimes look at is PR throughput. And definitely, if, for example, your PR has a lot more code, then it would take a longer time for other people to review it, for developer to add that code for that feature to be working. And it's definitely probably making AI systems make it more possible for you to generate and create more code. Um, and not sure exactly kind of what the future with this is, but the idea that everyone had, for example, the AI systems will increase the PR throughput and merging a lot more code. I mean, creating maybe more PRs is not the reality because there's just too much code, and we just maybe are using the wrong metrics here, and there is a mismatch between what has been before versus the speed that AI allows us to produce that code with. So there's more code, but I think maybe the final metrics should be slightly different rather than what has been before or what has been popular in DevOps, such as PR size or PR throughput.
So again, a fairly significant shift. So what are some of the important metrics that you look at?
I work at a more local level, and I come from the testing background, and I deal with front-end test frameworks. And some of the important metrics for me specifically is how long developers wait for our tests to run so they can go to the next step or before they get feedback. So things like test suite runtime, test file or test case runtime, and those are our primary metrics for developers to be happy with creating the PR and getting some sort of a feedback. I think that's kind of the main one for us. We don't look for there are probably a lot more other metrics that people at my company are looking at, but for our team, for our level, that's the main one.
And there's an abundance of tools. How do we choose?
I think that at this time, especially for in my work, I consider ourselves more a reactive team, and when we see a problem, we sometimes cannot foresee it, but when we see a problem, we should probably use whatever tools are available for us at that time, rather than spending time and investing too much into building our own things to predict whatever is going to come next. Um, as for example, for my previous work for all these tools for test generation or enzyme to RTL conversion, of course, we looked at all of the available tools, but there was nothing because some of those tools are not created with the kind of AI component in mind. And I think right now, a lot of my work or people in the DevOps role, they spend a lot more time on building the infrastructure for all of these AI tools to consume that information. Let's say in end-to-end testing, which is at the highest level of the testing pyramid, you sometimes get an error or a failed test, and it's very difficult to understand what the root cause of this, because your product, your application might be so distributed and there is no clear associations between some of those errors. Let's say you have 3 services and one service fails, but in your test, you only see that an element, for example, did not show up. It's a great use case for an AI system that can intelligently identify the root cause, but um, without the ability to get all of that information from all of those services while the test is running, it would be impossible. And those systems, those pipelines, they at this point do not exist. And I see it at my company that sometimes we're used to more traditional, typical use of, let's say, logs. where you have very strict permission rules so that you cannot get access to some of the information from your development environment where tests are running. So those are the things that I think it makes sense to invest and build in order to beef up these AI systems. So the more context you provide for them, the better they are. And I think for some of the tools that we've been building, that's how our work has changed. We are building this infrastructure and context collection tools rather than using AI for all of that. Calling, I think, AI endpoint or using an AI tool is probably the easiest, but collecting all of that other stuff is usually 80% of the success in the project.
What other advice, what else would you tell your peers about your experience using the generative AI tools in anger in the real world?
I would say one of the things that I saw among my peers and in other companies or on LinkedIn is that people are trying to build this very massive systems that can solve any kind of problem. But I think the best result that we got from our tools was when the scope is so minimal, the smaller the better. So try to analyze the problem that you are trying to solve and break it down as much as you can, and then try to solve and automate that one little piece. In that case, it's very easy to understand if it works or it doesn't work. You can, for example, if you can quantify the output, let's say, in our case, we usually count things like saving engineering hours. How long it would take me to do that one little thing? And let's say we save 30 seconds, but we run our test 30,000 times a month. So there you go. That's some sort of metrics that you can go and tell to your managers or present to the company so that you can get more time and more resources to build this system and show that there is an actual impact. So go very small and then try to show impact. I think those are two things. I guess the third one is just try it out. If it doesn't work, then it's all right. And if it's a small project, then you wouldn't waste too much time. And always there's the learning part in it.
Sergii, lots of good advice and interesting points here. If people want to continue the conversation, where do they find you?
They can find me on LinkedIn. My name is Sergii Gorbachov.
We'll include that link in the show notes.
Perfect. Yeah.
Thanks so much for taking the time to talk to us today.
Thank you.